February 1944. A small, windowless room deep within the Heereswaffenamt, Germany's army weapons office in Berlin. 3 engineers hunched over a collection of serial numbers, their faces drawn with exhaustion. These weren't random digits. They'd been painstakingly collected from destroyed and captured Sherman tanks across North Africa, Italy, and the Eastern Front. Using statistical analysis, a method the Allies would later call the German tank problem, these men were attempting to estimate American production capacity. The technique was elegant. By examining the sequential serial numbers on tank components, gearboxes, chassis plates, engines, they could mathematically extrapolate total output. It had worked brilliantly when analyzing Soviet 34 production. Now they applied it to the Americans. The chief engineer, a 48-year-old veteran of the Great War named Klaus Hoffmann, double-checked his calculations for the 3rd time that morning. His pencil hovered over the final figure. Then he set it down. The number was impossible. According to their analysis, American factories were producing approximately 270 Sherman tanks per month, not per year. Per month. His colleague, Werner Schmidt, suggested they'd made an error. Perhaps they'd confused individual tank production with component production. But when they cross-referenced serial numbers from different components, wheels, transmissions, hull plates, the mathematics remained consistent. The Americans were building Shermans at a rate Germany couldn't comprehend, much less match. What made this discovery particularly devastating was timing. In February 1944, German factories had just achieved their peak Panther production, 380 units in a single month. The engineers had celebrated this milestone. It represented a doubling of output from the previous year. Now, staring at calculations suggesting Americans were producing roughly 1,500 Shermans that same month, celebration turned to dread. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The intelligence report these engineers prepared was delivered to Albert Speer's Ministry of Armaments and War Production on February 23, 1944. It landed like a bomb. Senior Wehrmacht officers initially dismissed it as statistical error or Allied deception. The numbers simply couldn't be accurate. American industrial capacity, while formidable, couldn't possibly exceed German output by a factor of 5. Germany, after all, possessed some of the most advanced manufacturing infrastructure in the world. Their engineers had pioneered precision machining, their workers were highly skilled, and their tank designs were technically superior. How could the Americans, with their supposed emphasis on consumer goods and commercial manufacturing, be burying the Reich under an avalanche of armor? The answer lay in a philosophical difference so profound that German military planners had never seriously considered it. While Germany built tanks like master craftsmen creating individual masterpieces, America had reconceived the entire process. They weren't building tanks. They were manufacturing them on automotive assembly lines at speeds that made factory output more important than battlefield performance. This wasn't war, as Germany understood it. This was industrial warfare, and the Americans had rewritten the rules. To understand how German engineers reached this moment of horrified realization, one must travel back to May 1940, when most of Germany's leadership believed America posed no serious threat whatsoever. Joseph Goebbels, Hitler's propaganda minister, had quipped that Americans only knew how to make razor blades and refrigerators. This contempt wasn't entirely baseless. In 1939, the United States Army ranked 39th in the world, smaller than Romania's. American tank production for 1940 totaled a paltry 331 units. Germany, by contrast, produced approximately 2,400 tanks that year, while simultaneously conquering France. The American military establishment in 1940 was a relic. Horse cavalry still pulled artillery. Officer training emphasized traditions dating to the Civil War. The nation's armored doctrine was virtually non-existent. When France fell in June 1940, America didn't even possess a medium tank design suitable for mass production. The M2 medium tank, America's frontline armor, mounted a 37mm gun in a riveted hull that would have been outclassed on any European battlefield. Senior Wehrmacht officers reviewing American military capabilities in mid-1940 concluded, accurately, that the United States couldn't field a combat-ready armored division for at least 2 years. What these German analysts catastrophically underestimated was American industrial potential. The United States in 1940 possessed something Germany lacked entirely: vast overcapacity. The Great Depression had idled thousands of factories. Automobile plants capable of producing 15,000 vehicles daily sat partially empty. Machine shops that could manufacture anything from refrigerator components to aircraft engines operated at half capacity. Millions of skilled workers, from welders to machinists to tool and die makers, were either unemployed or underemployed. This wasn't a weakness. It was a coiled spring waiting for compression. President Franklin Roosevelt understood this before most of his own generals did. On May 28, 1940, 11 days after Germany's panzers reached the English Channel, Roosevelt delivered a message to Congress, requesting 50,000 aircraft per year. The number seemed absurd. America's entire aviation industry had produced fewer than 6,000 planes in 1939. Aviation experts testified that Roosevelt's target was physically impossible. The industrial capacity simply didn't exist. What they failed to grasp was that Roosevelt wasn't requesting 50,000 specialized aircraft built in dedicated aviation plants. He was demanding that America's automotive industry, with its proven mastery of mass production, be retooled to build wings instead of fenders. The man Roosevelt tapped to make this impossible demand reality was William Knudsen, a 61-year-old Danish immigrant who'd risen from bicycle mechanic to president of General Motors. Knudsen understood something that traditional military procurement officers didn't. Complexity was an illusion. Any machine, no matter how sophisticated, could be broken into simple, repeatable operations. Henry Ford had proven this with the Model T. Knudsen proposed applying the same philosophy to tanks. In a Pentagon conference room in May 1940, he told a gathering of skeptical Army generals that he could manufacture tanks with the same efficiency Detroit-produced Chevrolets. The generals laughed. One openly mocked him. How, they demanded, could civilian automobile workers, most of whom had never seen a military vehicle, build something as complex as a tank? Knudsen's answer was brutal in its simplicity. You break the tank into components. You assign each component to a dedicated production line. You train workers to perform one specific task, one perfect weld, one precise bolt installation, repeated hundreds of times per shift. You eliminate variation, standardize everything, and build jigs that make precision automatic rather than dependent on worker skill. The tank stops being a weapon and becomes a product. The generals remained unconvinced, but Roosevelt gave Knudsen unprecedented authority. In May 1940, the president established the National Defense Advisory Commission and appointed Knudsen, Director of Industrial Production. Knudsen accepted no salary, he held no military rank, yet he wielded power to reshape American manufacturing that no civilian had possessed since the Civil War. Within 90 days, Chrysler's tank arsenal broke ground in Warren, Michigan. The facility would eventually cover 113 acres of former farmland. Knudsen set a target that even his own engineers found disturbing. 1 tank every hour within 2 years. Not a goal, a demand. American industry would achieve this, or Nazi Germany would prove unstoppable. There was no middle ground. The German intelligence services monitoring American industrial mobilization in late 1940 noted these developments with interest, but not alarm. Yes, the Americans were building new factories. Yes, Roosevelt was making grand pronouncements. But talk was cheap. Actually producing modern armored vehicles at scale required more than enthusiasm and factory space. It required institutional knowledge, trained workers, supply chains for specialized components, and years of experience. Germany possessed all of these. America possessed none. This assessment wasn't unreasonable. When Chrysler's tank arsenal opened in January 1942, it was chaos. Workers reported to buildings where concrete was still curing. Assembly lines existed as chalk marks on bare ground. Crates of tank components accumulated in parking lots under tarpaulins because no one had designated storage locations. The first M3 Lee medium tanks assembled there required 2 weeks each, slower than the craftsman approach Knudsen had promised to surpass. German observers, receiving intelligence reports about these production disasters, concluded their initial assessment had been correct. Americans lacked the discipline and technical sophistication for tank manufacturing. What German intelligence failed to recognize was that American engineers were doing something unprecedented. They weren't trying to replicate German manufacturing methods. They were inventing entirely new ones. Traditional tank production treated each vehicle as a unique creation. Skilled machinists worked from blueprints, hand-fitting components, making adjustments. This approach guaranteed quality, but made speed impossible. Chrysler's engineers rejected this philosophy entirely. They dissected the tank into sub-assemblies: hull, turret, engine, transmission, suspension, electrical system, armament. Each sub-assembly got its own dedicated production line. Workers at each station learned one task, executed with jigs that eliminated guesswork. The training program was revolutionary. Traditional welding apprenticeships required 3 to 5 years. Chrysler's program took 8 weeks. New workers didn't learn comprehensive welding theory. They learned one specific weld in one specific location, practiced on scrap metal until their reject rate dropped below 2%, then moved to production lines. A former restaurant cook could be welding armor plate within a month. A sharecropper from Alabama could install transmissions. The assembly line philosophy, perfected by Henry Ford for automobiles, was being surgically applied to weapons of war. By March 1942, Chrysler's line finally established rhythm, producing 4 M3 Lees per day. Still far from Knudsen's vision, but progress. Then the Army changed everything. They demanded the new M4 Sherman tank instead. Superior design, but entirely different production requirements. Every jig, every tool, every training program developed for the M3 became obsolete overnight. Knudsen didn't waver. War doesn't accommodate perfect conditions. The retooling commenced immediately, even as M3s continued rolling off existing lines. 2 different tank types, 2 assembly lines, operating simultaneously in one factory with zero margin for error. This was American industrial warfare. The M4 Sherman, appearing on blueprint paper in August 1941, was a 30-ton mechanical nightmare from a mass production perspective. 8,000 individual parts, not counting 50,000 rivets in some variants. The Wright R975 radial engine alone contained 847 components. The transmission required 23 precision gears machined to tolerances of 1/1000th of an inch. The vertical volute suspension system employed 48 bogie wheels per tank. Army ordnance had designed it for battlefield superiority, not factory efficiency. Knudsen's engineers, reviewing specifications, immediately grasped their task. Surgically dissect this beast, simplify every element, render it so straightforward that someone's grandmother could assemble a section without error. The breakthrough came from John Wildley, a General Motors engineer who'd spent 20 years designing Cadillac transmissions. In September 1941, he sketched a concept that would revolutionize Sherman production. Treat the tank not as a single machine, but as 7 major sub-assemblies constructed simultaneously in different locations, then married together during final assembly. The hull alone subdivided into 22 separate stations. Station 7 installed transmission mounting brackets. Station 14 welded the bow gunner's hatch. Each station performed one task. This wasn't tank building. It was choreographed industrial ballet involving 300 workers executing movements in perfect sequence. The Ford River Rouge plant elevated this to an art form through vertical integration. Raw iron ore entered one end. Finished tanks emerged from the other 48 hours later. Steel was fed into blast furnaces, rolled into armor plate in dedicated mills, cut to specifications in stamping facilities, welded into hulls in Building B, mated with engines from Building C. Everything except the main gun was fabricated on site. The advantage was immediate. Design flaw discovered. Corrected at the steel mill, observed on finished tanks within 2 days. Contrast this with German production, where external suppliers meant weeks of delay. The relentless pursuit of speed encompassed systematic eradication of every delay. The Sherman's turret presented a particular challenge. Early designs required a massive 3-ton casting. Only a handful of American foundries possessed the capability to pour castings this large. The reject rate was brutal. Nearly 40% failed quality inspections due to internal air pockets or cooling cracks. Each failure meant remelting tons of steel and a 2-week schedule setback. Pacific Car and Foundry in Seattle devised an ingenious solution, a welded turret using multiple flat plates instead of one complex casting. Heavier, less elegant, but the production yield soared to 94%. Knudsen immediately sanctioned this modification, overriding Army objections. His standard was clear. Tanks on battlefields, actively engaged, infinitely preferable to theoretically perfect tanks confined to drawing boards. Standardization became sacred doctrine as multiple factories commenced Sherman production. Chrysler, Fisher, Ford, Federal Machine, Pacific Car, Pressed Steel, Baldwin Locomotive. Each initially wanted to implement improvements. Chrysler believed its transmission superior. Fisher advocated alternative engine mounts. Knudsen brutally suppressed these inclinations. His mandate was unequivocal. Every factory would build identical Shermans using identical specifications, identical tooling, identical processes. Interchangeability was paramount. A transmission fabricated in Detroit had to fit a hull produced in Chicago. This wasn't engineering vanity, it was battlefield logistics. When a Sherman threw a track in North Africa, repair crews couldn't afford time ascertaining the factory of origin before selecting replacement components. Standardization translated directly to operational efficiency. A tank disabled Monday could be fighting again Tuesday. Any deviation meant a potentially fatal delay. The workforce streaming through factory gates in early 1942 bore little resemblance to highly skilled machinists Army brass had envisioned. Consider Anna Kowalski, serving coffee in a Detroit diner 2 weeks prior, now expertly welding hull plates on Chrysler's assembly line. James Washington, a 58-year-old sharecropper from Alabama whose most complex experience had been guiding a mule plow, now installed intricate transmission assemblies. Margaret Chen, barely 5 feet tall, navigated confined turret spaces to wire electrical systems, accessing areas engineers presumed only smaller men could reach. By mid-1942, over 40,000 individuals engaged in Sherman production across multiple plants. Astonishingly, approximately 65% possessed absolutely no prior manufacturing experience. Knudsen had anticipated this. Wars aren't won waiting for skilled workforces to emerge. One must cultivate such workforces from whoever is available. The training system Bailey designed was brutally efficient precisely because it jettisoned antiquated notions of creating broadly skilled craftsmen. Anna's first day, she wasn't burdened with welding theory, metallurgy, or proper torch angles for 8 materials. Her instruction was laser-focused, one specific weld. The vertical seam where the hull side meets the hull bottom on the M4A3 variant. That was her curriculum. Her instructor, a seasoned pipeline welder from Texas, dedicated 4 hours demonstrating exact torch distance, precise feed rate, specific motion pattern. She practiced on scrap metal 8 hours until the weld bead was flawlessly identical every attempt. By day 3, she'd transitioned to production lines, executing the weld dozens of times per shift. Station 23 became her operational universe. She attained such proficiency that her reject rate plummeted below 2%. superior to many workers boasting 10 years general welding experience. However, training velocity inevitably birthed quality control nightmares. In March 1942, 47 Shermans failed Army acceptance tests because internal welds on ammunition racks were substandard. These welds would crack under sustained firing vibration, risking catastrophic detonation of the tank's own shells, killing crews. Inspectors traced the problem to a training class where the instructor, overwhelmed by 200 recruits, had cut corners on penetration depth instruction. These inadequately trained workers produced defective welds for 2 weeks before detection. Every tank they'd touched required line pullback, meticulous disassembly, re-welding, painstaking re-inspection. The delay cost 11 precious production days. Knudsen's response wasn't decelerating training. He mandated more inspection stations. Every 7th Sherman underwent complete disassembly by quality control teams, scrutinizing every weld, bolt, tolerance. Brutal, seemingly wasteful, yet immensely effective, catching critical problems before tanks reached battlefields. The factories operated relentlessly. 3 shifts, 24 hours daily, 7 days weekly. Night shift, 11 p.m. to 7 a.m. Universally acknowledged most arduous. Workers grimly dubbed it the zombie shift because human bodies never truly adjusted. Biological instincts designed for sleep during these hours, fighting against them took heavy toll. Productivity consistently dropped 15% on night shifts. Injury rates doubled. Dorothy Martinez, working turret assembly at Fisher Body, succumbed to exhaustion, fell asleep standing at 3 a.m. Her hand drifted into a moving conveyor belt. She lost 2 fingers, yet the factory's pace didn't falter. Her station was filled within 20 minutes by a floater worker trained to step in during emergencies. Dorothy, demonstrating remarkable resilience, returned to a different station 3 weeks later. Missing fingers and the cold calculus of wartime production didn't disqualify a worker. Only complete loss of hands did. The diverse workforce transformed factories into peculiar self-contained communities. Many workers relocated from across America, drawn by defense jobs, essentially lived at plants. Chrysler constructed on-site dormitories housing 3,000 workers. The cafeteria served 15,000 meals daily across all shifts. Within the complex, a barber shop, fully equipped medical clinic, even a small post office operated. Children attended daycare in converted storage buildings, while mothers welded armor plate 200 feet away. The conventional boundary between civilian life and war production demands completely dissolved. Workers ate where they toiled, slept near workplaces, and their closest companions were individuals sharing their station. When the factory public address system boomed with Allied victory announcements during lunch breaks, cheers reverberated off steel rafters. Every worker understood those were their tanks, their collective effort, winning those battles. Each Sherman rolling off the line carried within its steel shell a fragment of 40,000 individual stories, the vast majority never fully told. April 12, 1943 marked the momentous occasion when Knudsen's impossible promise became tangible reality. At the Grand Blanc tank arsenal, an immense complex sprawling across 113 acres of former Michigan farmland, Sherman tank number 1000 gracefully rolled off the assembly line at precisely 2:47 p.m., a mere 55 minutes after Sherman 999 had preceded it. The plant had finally achieved the synchronized rhythm Knudsen had boldly envisioned 3 years prior, a vision initially drawing laughter from high-ranking generals. A complete M4A3 Sherman medium tank, fully assembled, every system, rigorously tested, unequivocally combat-ready, now emerged from final inspection every 55 to 60 minutes, hour after hour, shift after relentless shift. Germans were producing approximately 500 tanks monthly across their entire industrial capacity. Grand Blanc plant, operating alone, was now matching that formidable number. And crucially, it wasn't the only factory engaged in Sherman production. Walking along Grand Blanc's line during peak production felt akin to witnessing industrial ballet, choreographed by a brilliant, perhaps mad visionary. The main assembly line stretched nearly half a mile. Overhead conveyors silently transported major components with breathtaking synchronization. Every 6.5 feet of movement on the line represented 1 minute of intense production time. At commencement, raw, newly welded hulls arrived from fabrication buildings, still exuding warmth from recent welds. Workers at Station 1 were allotted precisely 55 seconds to securely bolt transmission mounting frames before hulls inexorably moved to Station 2. There was no frantic rushing. Rushing inevitably led to costly mistakes. Instead, every motion was meticulously optimized down to specific hands used to grasp individual bolts. The workers themselves moved with the same mechanical precision as formidable machines they assembled, a testament to months repeating identical motions 400 times per shift. Among numerous advancements, the suspended track assembly system emerged as most distinctive. Conventional tank fabrication necessitated laborers physically hoist and maneuver cumbersome track sections into place, an exceedingly arduous task, significantly impeding production pace, frequently resulting in severe back injuries. Engineers at Grand Blanc devised sophisticated systems where tracks suspended from ceiling-mounted cranes precisely synchronized to move seamlessly with assembly line progression. As each Sherman advanced along the production path, tracks descended with impeccable timing, arriving the precise instant suspension bogies were prepared for installation. Workers deftly guided heavy components into designated positions, while pneumatic tools efficiently secured connecting pins within 90 seconds. This streamlined process dramatically reduced what was previously a laborious 45-minute operation to less than 2 minutes. When extrapolated across daily output of 16 tanks, the facility could suddenly boast production of an entire extra battalion weekly, a monumental increase derived solely from operational enhancements. The engine marriage station represented a pivotal juncture, a critical point where intricate components either coalesced flawlessly or catastrophically unraveled. Here, the Continental R975 radial engine, weighing a substantial 1,100 pounds, had to be meticulously joined with transmission and precisely connected to vital systems: fuel lines, oil lines, coolant lines, electrical harness, exhaust manifold. All this complex integration accomplished within an exacting 12-minute time frame. A team of 4 highly trained workers surrounded each tank, executing a precisely choreographed sequence. The first expertly lowered the massive engine using overhead hoist, while the second meticulously guided it onto designated mounting studs. Simultaneously, the third diligently connected transmission coupling as the fourth busily established electrical connections. Throughout this intricate ballet, not a single word was exchanged. Communication among the team was exclusively through complex hand signals, a necessity born from overwhelming factory floor cacophony. The relentless din of hammering, searing hiss of welding, roar of engine testing, grating screech of metal rendered verbal conversation utterly futile. So ingrained was this particular sequence that workers had executed it countless times, rendering spoken commands entirely superfluous. Each individual instinctively anticipated colleagues' next actions, guided by almost uncanny shared muscle memory transcending explicit instruction. Within Grand Blanc, rigorous quality control ascended to unwavering doctrine status, for it was unequivocally understood that mere speed devoid of inherent reliability was utterly meaningless. Consequently, every single tank fabricated underwent a grueling ordeal known as the death run. This formidable 3-mile course, meticulously laid out on factory grounds, incorporated harrowing challenges: treacherous mud pits, formidable steep hills, unforgiving sharp turns, obstacles specifically engineered to push every system to absolute limits. Engines were driven at full throttle. Transmissions shifted through every gear under immense load. Suspensions forced to absorb impacts precisely simulating brutal battlefield conditions. Should any component exhibit failure, a telltale oil leak, ominous transmission grind, disruptive track throw, electrical fault, the Sherman was instantly withdrawn. The specific defect was meticulously traced back to its originating station and the worker deemed responsible immediately retrained, ensuring swift correction and continuous improvement. Despite stringent testing, initial reject rates consistently hovered around 8%, signifying approximately 1 in 12 tanks failed preliminary evaluations. However, these seemingly concerning failures were in fact essential filters, ensuring the remaining 92% ultimately deployed to North Africa, Italy. Eventually, Normandy battlefields possessed systems thoroughly proven and hardened under extreme stress. There was palpable collective aversion to having one's workmanship linked to tanks faltering in combat, particularly if such failure could be attributed to insufficient training or substandard production practices. By summer 1943, collective American Sherman production from all manufacturing facilities reached an astonishing peak with 2,200 units completed in July alone. This singular month's output dramatically surpassed the entirety of German tank production for the entire year of 1941, underscoring the formidable power of American industrial might. The visionary assembly line concept had delivered precisely what Knudsen pledged. It transformed the immense latent capacity of American industry into an irresistible, overwhelming torrent of armored vehicles. Soviet military officers, upon visiting sprawling Detroit factories, were reportedly struck into silent awe, observing Shermans emerge with almost metronomic regularity. Their subsequent reports to Stalin conveyed profound bewilderment, stating American production capability was simply beyond human comprehension. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Similarly, British forces, beneficiaries of thousands of Shermans supplied through the vital Lend-Lease program, were able to completely reconfigure and rebuild entire armored divisions, anchoring combat strength around these American-made tanks precisely because their own domestic output couldn't possibly rival sheer volume. The achievement of manufacturing a Sherman in just 60 minutes transcended mere production engineering feat. It marked a pivotal historical juncture where industrial capacity itself evolved into a weapon, proving more strategically decisive than any conventional firearm. Back in Berlin, that February 1944 intelligence report sat on Albert Speer's desk for 3 days before he read it. Germany's Minister of Armaments and War Production had just recovered from serious illness, a lung embolism that nearly killed him in January. He was exhausted, overwhelmed, and utterly unprepared for what the statistical analysis revealed. The numbers were impossible. They had to be impossible, yet the methodology was sound. The serial number analysis technique had worked flawlessly when applied to Soviet production. There was no reason to doubt it now. Speer immediately convened an emergency meeting with his senior production engineers. The question wasn't whether the Americans were outproducing Germany. That much was evident from battlefield reports. The question was by how much. The statistical analysis suggested a production disparity of approximately 5-1. For every Panther Germany built, America was building 5 Shermans. For every Tiger, 25 Shermans. The room fell silent. One engineer, a veteran of the Great War, finally spoke. "This isn't a war we can win through superior engineering. This is a war of factories, and we're being buried alive." The German response to this intelligence was predictably bureaucratic and ultimately futile. Speer ordered increased production targets. German tank output for 1944 would indeed reach record levels. 17,300 tanks of all types, more than triple the 1941 production. This was Speer's so-called armaments miracle, achieved through ruthless efficiency improvements, extended work shifts, and the systematic exploitation of slave labor from concentration camps. Yet even at peak production in July 1944, Germany produced approximately 1,400 tanks that month. America produced over 1,600 Shermans alone in that same period, not counting light tanks, tank destroyers, or other armored vehicles. The mathematics were brutal and inescapable. Germany was fighting a 3-front war: Eastern Front against Soviets, Western Front against Americans and British, and Mediterranean theatre in Italy, while simultaneously facing strategic bombing that destroyed factories faster than they could be rebuilt. America faced no such constraints. Detroit operated in perfect safety, 3 shifts daily, supplied with unlimited raw materials. Allied bombers struck the Alcott factory in Berlin, crucial producer of Stug 3 assault guns. In March 1944, it required 4 months returning to previous production capacity. The Henschel plant in Kassel, responsible for constructing formidable Tiger tanks, was bombed 6 times between September 1943 and March 1944, each strike inflicting weeks of debilitating delays. Meanwhile, American Sherman production facilities never faced bombing threat, operated tirelessly, enjoyed unfettered access to essentially unlimited raw materials. Steel shortages were alien concepts in Detroit. Aluminum was readily abundant. Rubber flowed from both natural plantations and advanced synthetic sources. After 1943, this immense resource disparity meant German factories engaged in desperate struggles, merely maintaining existing output, while American factories relentlessly optimized processes to accelerate construction of even greater numbers. The logistical framework Sherman production engendered proved almost as critically important as tanks themselves. Each Sherman required continuous supply of spare parts, ammunition, fuel, specialized maintenance equipment. American factories didn't merely construct 49,234 tanks. They meticulously built robust support infrastructure necessary to sustain such vast fleets. This included immense inventories of spare transmission assemblies, countless replacement tracks, comprehensive engine rebuilding kits, myriad electrical components. The famed Red Ball Express supply routes established in France following D-Day transported an astonishing 12,000 tons of supplies daily, with significant portions dedicated to Sherman-related logistics. German units frequently found themselves compelled to abandon even repairable Panthers due to crippling deficiencies of spare parts or necessary recovery vehicles. American maintenance battalions, leveraging standardized interchangeable parts from any factory, could rebuild damaged Shermans, return them to active service within a remarkable 72 hours. This unwavering emphasis on interchangeable components, cornerstone of assembly line philosophy, ensured entire logistical systems operated with the same impressive efficiency as production lines themselves. The crews themselves also constituted integral parts of this overwhelming quantity advantage. By 1944, training a panzer crew typically required grueling 6 months, primarily because Germany suffered severe fuel shortages, precluding extensive practice. Experienced instructors were perishing on front lines faster than they could be replaced, and every tank allocated for training represented one fewer available for combat. American tank training boasted Sherman mock-ups, unlimited ammunition supply for practice, dedicated training facilities strategically located far from combat zones, and perhaps most crucially, ample time. A crew could undergo a comprehensive 4-month training regimen stateside, then arrive in Europe to take command of brand new Shermans that literally rolled off assembly lines the very week they shipped out. The industrial system didn't merely produce tanks, it meticulously cultivated pipelines of highly trained crews perfectly matched to a relentless production pace. By pivotal year 1945, the American armored force had evolved into a truly self-sustaining synergistic ecosystem where production, training, logistics, replacement mechanisms all operated with the same relentless, synchronized pace. Germany, confronting such an overwhelming, systematically dominant force, simply never stood a chance. The Shermans didn't necessarily need superior individual technical specifications, they merely needed to keep coming, and with an unwavering torrent, they never stopped. The final accounting is stark and speaks volumes about industrial warfare's true nature. Between early 1942 and mid-1945, American manufacturing facilities rolled out an astonishing 49,234 Sherman tanks. It is imperative to contemplate this figure deliberately, for it vividly illustrates monumental industrial chasm that unequivocally determined armored warfare's course during global conflict. Germany managed constructing approximately 6,000 Panthers, their premier medium tank boasting technical specifications largely superior to Sherman's across almost every metric. Furthermore, they produced roughly 1,350 formidable Tigers, terrifying behemoths capable of obliterating Shermans at distances where retaliatory fire from American vehicles proved utterly futile. Theoretically, German engineering prowess reigned supreme, yet on actual battlefields, this technological excellence was effectively submerged beneath an overwhelming deluge of American production. For every Panther meeting destruction, relentless tide of 3 additional Shermans invariably emerged to take its place. The cold, impartial logic of mathematics holds little regard for individual quality when sheer volume reaches truly biblical proportions. The Soviet Union's contribution provides a pivotal perspective to this narrative. The 34, widely regarded as arguably the most effective tank design of entire war, saw astonishing production of roughly 84,000 units. When combined, armored vehicle output from American and Soviet factories collectively amounted to approximately 180,000 tanks. Conversely, Axis powers Germany, Italy, Japan jointly managed producing only about 50,000. This meant Axis nations were simultaneously engaged in devastating 3-front war against adversaries manufacturing tanks at nearly 4 times their combined rate, a truly insurmountable challenge. German tank crews frequently recounted the harrowing psychological impact of destroying 5, 6, even 7 Shermans in single engagements, experiencing fleeting sensation of victory, only to witness 10 more cresting next ridge behind them. This tactical superiority, while impressive in isolated instances, became strategically meaningless when the enemy possessed inexhaustible capacity absorbing losses Germans simply couldn't. Every Sherman brood represented perhaps 2 hours of American production capacity, negligible cost in grand scheme. Every Panther loss signified 2 weeks of German resources, crippling expenditure they were unable to recover. This profound asymmetry in replacement rates utterly dismantled German armor doctrine. Foundational principles of panzer divisions in 1944 were predicated on belief that technologically superior tanks, expertly commanded by seasoned crews, could decisively overcome numerically larger forces through sheer tactical brilliance. This approach had indeed yielded early triumphs in campaigns across Poland, France, initial stages of Russian front when German tanks were newer, crews of exceptionally well-trained logistics networks that could reliably keep units supplied. However, by late 1944, these crucial assumptions had completely shattered. A German panzer division suffering loss of 30 tanks in battle might face an agonizing wait of 3 months for replacements. Direct consequence of German factories unable maintaining sufficient production pace. Conversely, American armored division losing 50 Shermans would typically receive full replacements within 2 weeks, sometimes even days. Units that by conventional military standards should have been rendered combat ineffective after heavy engagements were back at full operational strength before German intelligence agencies could even update casualty reports. The Americans weren't achieving victory through superior tactics alone. They were prevailing through an overwhelming force of industrial inevitability. The relentless strategic bombing campaign further exacerbated this already catastrophic production disparity for Germany. When Allied bombers struck German synthetic fuel plants in mid-1944, panzer divisions literally ran out of gas. The Ardennes offensive in December 1944, Battle of the Bulge, was predicated on German forces capturing American fuel depots because they lacked sufficient fuel completing operations otherwise. The crude training pipeline reveals another dimension of American industrial superiority, U.S. Tank training schools at Fort Knox and Fort Benning graduated thousands of crews annually, each receiving 12 to 16 weeks instruction. When Sherman crew was killed, 5 trained replacements existed stateside. Germany's training pipeline collapsed by 1944. Replacement crews received weeks instead of months instruction, often never seeing specific tank models they'd operate in combat until arriving at fronts. Inexperienced crews magnified mechanical unreliability. They didn't know how operating complex systems properly, leading to more breakdowns and combat losses. The strategic bombing campaign that American industry enabled closed the loop. Same factories building Sherman's built B-17 and B-24 bombers by thousands. Those bombers systematically destroyed German industrial capacity from 1943 onward. Ball-bearing plants at Schweinfurt, synthetic oil facilities in Ruhr, locomotive works moving supplies, all targeted because American intelligence knew Germany's war economy couldn't absorb disruption the way America's could. When Allied bombs destroyed the German tank factory, it stayed destroyed. America could lose an entire factory and simply build another. William Knudsen passed away on April 27, 1948 in Detroit, largely in relative obscurity. There was no grand state funeral, no prominent memorial erected on the National Mall. The New York Times dedicated mere 4 paragraphs to his passing on page 23. Vast majority of Americans who'd either driven Chevrolets or served bravely in Sherman tanks had no conception who he was. Yet this was the man bestowed with a truly unique honor in American history. President Roosevelt personally commissioned him directly from civilian life to rank of lieutenant general in January 1942, unprecedented act that saw him skip every single rank from private to 3-star general. He proudly wore uniform for 3 years, never once commanded troops in field, never fired shot in combat, yet arguably contributed more to Allied victory in World War II than most battlefield commanders. General Dwight Eisenhower himself later asserted Knudsen's contribution was as critically important as any general. Nevertheless, history in its often fickle judgment relegated him to footnotes while celebrating tank commanders who drove very vehicles his ingenious system created. The assembly line doctrine Knudsen brought to profound perfection didn't perish with him. Instead, it permeated, metastasized into every corner of military production. The colossal B-24 Liberator bomber production facility at Willow Run directly applied Sherman assembly principles, eventually achieving a staggering output of 1 bomber per hour. Monumental Liberty ship program constructed cargo vessels in astonishing 42 days using modular construction methods directly copied from tank production. In post-war era, Pentagon permanently embedded civilian production experts into military procurement processes. Evocative concept of arsenal of democracy was no longer merely poetic language. It had been codified into official doctrine. America would never again rely on slow, bespoke military contractors hand-building weapons. Henceforth, everything from immense aircraft carriers to individual artillery shells would be meticulously designed for mass production from first day of conceptualization. Future wars, it was understood, would be won in factories long before soldiers fired first shots. The Cold War defense industry ultimately became a culminating achievement of Knudsen's enduring legacy. As the Soviet Union emerged as a formidable new threat, American military planning unequivocally centered on production advantage. The M48 Patton tank, M113 armored personnel carrier, M16 rifle were all designed with manufacturability as paramount requirement, not mere afterthought. Defense contractors were compelled to demonstrate proficiency, producing weapons at immense scale, not just fabricating technically superior prototypes. This philosophy reached a veritable pinnacle with development of the Monet Abrams tank in the 1980s. The Lima Army Tank Plant in Ohio, constructed directly upon foundational principles of Sherman production, possessed capacity producing astonishing 120 Abrams tanks monthly, meaning 60-ton main battle tank rolled offline every 6 hours. While these numbers didn't quite reach unprecedented levels of Sherman production, underlying philosophy remained identical, overwhelmed through sheer production capacity rather than marginal technical superiority. The civilian production model's pervasive impact extended far beyond military hardware. It fundamentally reshaped how America conceived industrial mobilization. The 1950 Defense Production Act, legislation remaining in effect today, granted the president sweeping authority, compelling private companies prioritizing government contracts during national emergencies. precisely mirroring informal authority Knudsen exercised during 1940–41. Strategic National Stockpile, FEMA's Comprehensive Emergency Response Planning, even accelerated COVID-19 vaccine production efforts in 2020–21, all utilized frameworks originally developed during intense pressures of the Sherman production crisis. The radical idea that civilian industry could be rapidly converted to emergency production, that private companies and government could forge unprecedented collaborations at massive scale, that speed mattered more than perfection in crisis. These were not natural or intuitive assumptions. Knudsen, through his groundbreaking work, unequivocally proved them viable at a time when most experts dismissed them as impossible. However, this dominant doctrine also harbored unacknowledged drawbacks and costs few wished discussing. The assembly line philosophy, in its zealous prioritization of quantity, sometimes led to fatal compromise in quality. Sherman crews regrettably paid a grievous toll for this in North Africa and Normandy, often perishing inside tanks that were indeed good enough to produce quickly, but demonstrably not robust enough protecting them adequately. This inherent institutional bias toward mass production meant the American military on occasion deployed suboptimal equipment simply because it could be manufactured with greater expediency. It was within this complex industrial landscape that Knudsen's extraordinary foresight truly shone, as he possessed unparalleled ability, discerning precisely when numerical superiority of production held greater strategic importance than refined excellence of individual units. However, very production framework he meticulously constructed, while undeniably revolutionary, occasionally extended this fundamental philosophy of mass output even into scenarios where intrinsic quality should undeniably have taken precedence. This sometimes led to prioritization of readily available, adequate resources over development of superior, albeit slower to produce alternatives. A comprehensive, truthful retrospective demands uncomfortable degree of candor. It is undeniable historical truth beyond serious academic contention that Knudsen's pioneering assembly line philosophy was decisive factor securing victory during World War II. The staggering total of 49,324 Sherman tanks, meticulously fabricated by diverse workforce, many possessing no prior experience in heavy manufacturing, channeled through industrial framework defying conventional military wisdom, this relentless torrent of armor effectively overwhelmed formidable Axis forces, achieving victory through sheer crushing numerical superiority. Nevertheless, it is equally true these very Shermans were, by objective technical metrics, demonstrably inferior to their German adversaries when evaluated on individual armor protection, destructive firepower, critical crew survivability. Consequently, American tank crews tragically perished in greater proportions. Direct outcome of production strategy, resolutely prioritizing swift deployment of sufficient operational tanks to front lines over time-consuming development of unequivocally superior models for later conflict stages. This strategic dilemma naturally provokes profound question. Was this indeed most judicious path forward? The irrefutable outcome, triumph of Allied forces, serves as history's resounding affirmation. Yet for valiant individuals who tragically perished in infernos of their vulnerable Ronson tanks, ethical considerations surrounding this choice might demand far more intricate and somber deliberation. Knudsen without doubt constructed formidable industrial engine propelling Allies to victory. However, whether he constructed ethically correct engine, one balancing overwhelming production with optimal protection for operators, remains deeply unsettling question, continuing to defy facile or universally accepted resolution. What stands as indisputable fact is that no other civilian figure in annals of American history ever wielded such profound, decisive influence over military triumph while simultaneously remaining so remarkably uncelebrated and largely unknown to broader public. This Danish immigrant, who audaciously pledged achieving what many considered utterly unattainable, delivered precisely that extraordinary feat. Subsequently, he receded quietly into peripheral footnotes of history, while very world he'd played such pivotal role in preserving largely neglected remembering his name. In its blend of immense achievement and profound anonymity, this narrative might very well encapsulate most quintessentially American story of entire global conflict. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.